Hello students, you are welcome to this mathematical journey with sirMATHS. Today we are going to treat sequences as it affects grade 9 equivalent to JSS 3. Sequences is an orderly list of numbers. An orderly list of numbers is a set of terms arranged according to a rule. It's a set of terms arranged according to rules. What do we mean by that? It is a list of numbers that you can find out the rule. It's that rule that informs you the next term after a given term. A number, or rather a list of this sort, 2, 4, 6, 8. This is a sequence because it is orderly listed. It is listed according to a rule. If you look at it, you will discover the rule that will enable you even to add a term or more when required. But a number like 7, 2, 1, 8, you may spend the whole day looking for the rule or what informs you that 2 should be written after 7. You may not find that. And what does that mean? This list is haphazardly listed. It is not a sequence. But here you can easily find a rule. Or what tells you what next to write another term after a given one. Here you can check. 4 minus 2 will give us 2. 6 minus 4 will give us 2. 8 minus 6 will give us 2. You discover here that the rule here is add 2 continuously. Or rather, a term plus 2 gives you the next. A term plus 2 gives you the next. So we call this a sequence because it is orderly listed. And when we are asked to find a rule, like we have found here, we simply say that it is a term plus 2. Or keep on adding 2. Just add 2 to get the next one. This is a sequence. Why it is orderly listed. You can easily know the rule. Like here, we can even add more terms when it is required from us. But I want you here to, first of all, know what is a sequence. A sequence is an orderly list of numbers. It is a set of terms that are written according to a rule. Each sequence has its own rule. There's no general rule. For example, here we have found the rule. The rule is add 2 to the previous term to get the next one. Another may be another rule, but a sequence must have a rule. If a list of numbers has no rule, then that is not a sequence, as we have indicated here. Now let us have some examples of a sequence where we may be asked to add more terms to that given sequence, and also to find a rule that sequence that is applied to that very sequence. Example, we have a sequence given this way. Let's use the one we have used previously. 4, 6, 8. And the question says, find A, the rule of the above sequence, and B, add more 3 times. So we first of all find the rule. We have our 2, 4, 6, 8. And we are asked to add more 3, give provision for a 3. And what is the rule? We have seen that if we subtract the first term from the second term, we are going to have 2. Subtract the second term from the third term, we are going to have 2, and that is continuous. So we now say that the answer to A is add 2. B, we already have 8. We now say 8 plus 2, that will give us 10. Have 10 here. And 10 plus 2 will give us 12. We have our 12. And 12 plus 2 will give us 14. So we have been able to find the rule of this very particular sequence. And then add more 3 using the rule we have found, because it is a rule that informs us that after 8, the next one should be 10, and so on. That is the definition of a sequence, and also how to find the rule which is necessary, because every sequence must have a rule. That is, let us have another example where we're asked to do the same thing. A, the rule. Let's take another sequence. One, 3, 5, 7, 9. We're expected to find have a solution 1, 3, 5, 7, 9. 1, 2, 3. We're expected to add. So we now first of all find the rule. What informs the writer that after 1, the next one should be 3? We can go this way. 3 minus 1 gives us 2. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. Therefore, we say that the rule is add 2. If the rule is add 2, what should be the value of 1, 2, 3, 4, 5? What should be the value of the 6th term, the 7th term, and the 8th term of this very given sequence? We now say 9 plus 2, that will give us 11. And the second one, 11 plus 2, will give us 13. And 13 plus 2 will give us 15. So we have 11, 13, and 15. You see, somebody can find a different rule if there are 3 or more persons that are expected to find the rule of this. Their answer may be different, but they will all be correct. Like somebody saying that the rule here is odd numbers. It's also correct. The rule is odd numbers. And the first example we had here, somebody can say that the rule is even numbers. 2 is an even number, 4 is an even number, 6 is an even number, 8 is an even number, 12, 14, 16, and so on and so forth. And here, somebody can say that the rule is odd numbers. 1 is an odd number, the same thing with 3, 5, 7, 9, 11, 13, 15. And that person will also be correct because that is the rule. Odd number from 1 to infinity. So these are examples. Here we have find each of them. We find the rule and then we add the more terms as required. That is for sequence, and we go on. Let's take another sequence. Like I told you, it doesn't mean that the rule each of them must be the same thing. The first one we had add 2, the second one we have add 2. It doesn't mean it must be add 2. It can be any number, like we are going to say in the let's have it here as a sequence 1, 6, 11, 16, we're expected to find the rule here and also to add more 3 terms. We have our solution 1, 6, 1, 2, and 3. What's the rule here? If you look at it, you can say term 2. The second term minus the first term will give you 5. That is 6 minus 1 is 5. And the 11 minus 6 will give you 5. 16 minus 11 will give you 5. 21 minus 16 will give you 5. We simply say that our answer to A is add 5. Keep on adding 5. And for B, we have 21 plus 5. That will give us 26. We write out 26. And we have 26 plus 5. That will give us 31. We have 31. And then 31 plus 5 will give us 36. That is 36. So we have find the rule, which is add 5. You add 5 to the previous one to get the next one. That is, if you add 5 to term 1, you will get term 2. You add 5 to term 2, it will give you term 3, and so on and so forth. And so, having found the rule, it has now guided us, giving us information, informing us what to be the next 3, which are going to be 26, 31, and 34. That is for this very particular sequence. We may as well have another one that will be expected to find the rule and also add more 3 terms. Let's have 100, 96, 92, 88, so we have in our solution 100, 96, 92, 88, then the more 3, 1, 2, 3. Will agree with me that if you subtract term 1 from term 2, you are going to have minus 4. Term 3 minus term 2 will give you minus 4. And term 4 minus term 3 will give you minus 4. So we have our answer for A, which is the rule. The rule here is subtract 4. If you subtract 4 from term 1, it will give you term 2. That is, if you subtract term 1 from term 2, it will give you minus 4. and so on and so forth. So based on this, we can add 1, 2, 3 terms. And that is B. We have 88 minus 4. That will give us 84. Then 84 minus 4 will give us 80. And 80 minus 4 will give us 76. So we have for here 84, here 80, while here we have 76. We have found a rule that says subtract 4. We have found the more 3 terms as we expected to do, giving us 84, 80, and 76. That is for this very particular sequence. It's possible to have, there are many sequences on and on. So this is the way you find a rule, and then add whatever more terms you are asked to find where necessary. Let's have another example. Let's have 20, 10, 0, minus 10, and so on. We're expected to find a rule and also add more 3 terms. This is our 20, which is term 1, term 2, 10, term 3, 0, then 4 minus 10. 1, 2, 3, as we expected to do. What is the rule here? Term 2 minus term 1, which is 10 minus 20, will give us minus 10. And 0 minus 10 will give us minus 10. And minus 10 minus 0 will give us minus 10. So the rule here is subtract 10. You keep on subtracting 10, you should subtract 10 from a term, it will give you the next term, and so on and so forth. And so for B, we now have minus 10, minus 10. That will give us minus 20. Minus 20. And then minus 20 minus 10 will give us minus 30. And minus 30 minus 10 will give us minus 40. We have found the next 3 terms as we are expected to do. This is minus 20, minus 30, minus 40. So the rule for this very particular sequence is subtract 10. Subtract 10 from the given one to get the next one. And so you keep on doing. That is for this very particular one. Now we have seen that in each of these examples we have had, we have equal difference. Or what do I say? We have equal step. Equal step. The first one we had, each one was 2. That was equal step. And the second one and the third one, this very one we have solved. This is the same minus 10, minus 10, minus 10. Now let's go to another one, another example under this very sequence. Let's still leave this and also add more 3 terms. We have a number 1, 2, 4, Let us add more numbers to that, okay? 8, 16. To find a rule, and thereafter we find more 3 terms. This is 1, 2, 4, 8, 16. And we have 1, 2, 3. So what is our rule here? What is our rule? If we go by that method we're using subtracting, this 2 minus 1 is 1, 4 minus 2 is 2, 8 minus 4 is 4. You discover they are not equal steps. But if you look closely, you discover that 2 times 1 is 2, and 2 times 2 is 4, and 2 times 4 is 8, and 2 times 8 is 16. We quickly say that the rule is or multiply a term by 2 to give you the next one times 2. That is the rule here. And so by this rule we have found, we can now find the more 3 terms. How do we do that? We have 16 times 2. That will give us the 32 times 2 will give us 64. And 64 times 2 will give us 8, 2, 1, 128. So we now write here 32 and 64 and 128 times 2 as the rule here. That is for this very particular sequence. The rule here is multiply a term by 2 to give you the next term. Let us have another example to this effect that will involve multiplication. This time around, it's not addition as we had previously. Let's have this sequence as this is 2, 10, 50, 250. We expected to find a rule, and thereafter we add more 3 terms to it. We have 2, 10, 50, 250. 1, 2, 3 to be added. If we go by that first method we were using when we had equal step, it may not work here because 10 minus 2 will give us 8, and 50 minus 10 will give us 40. You can see that 8 and 40 are not equal. But you look at this, you discover that 2 times 5 will give you 10, and 10 times 5 will give you 50, and 50 times 5 will give you 250. So we now have for A is times 5. Times 5. That is the rule. Okay, let me use this for those who may get the project who can get confused. I mean times 5 as the rule for the very particular sequence. And so with this we can find the other 3 we expected to find. That is B. We have 250 times 5. That will give us 5 times 0 is 0. 5 times 5 is 25. Write 5 and carry 2. 5 times 2 is 10. And 10 plus 2 we carried. 10 plus 2 we carried is 12. So this is 1250. Then 1250 times 5. 5 times 0 is 0. 5 times 5 is 25. Write 5 and carry 2. 5 times 2 is 10. And 10 plus 2 is 12. We carry 1. 5 times 5 is 5 times 1 is 5. Plus the 1 we carry is 6. We have 6250 as the next term after 1250. And 6250 times 5 will give us 5 times 0 is 0. 5 times 5 is 25. We write 5 and carry 2. 5 times 2 is 10. 10 plus 2 is 12. We write 2 and carry 1. 5 times 6 is 30. 30 plus the 1 we carried is 31. So we have 6250 and 31250. These are the more 3 terms for this very particular sequence, whose rule is times 5. That is for this very one. We have found that. Now, let us look at these aspects of sequence. A sequence can be arithmetical or it can be geometrical. Let's look at the two situations. It could be arithmetical or geometrical. What are the examples for each of these? When a sequence is said to be arithmetical, this is arithmetic sequence. The rule will involve an equal step. That is, we say arithmetic sequences is a sequence that increases in an equal step. It increases in an equal step. Just like if you can see a staircase built by a good architecture, you discover that it will be equal. Next, you can see the height will be equal. This is where I'm referring, will be equal. No. Staircase is increasing by an equal step. This length is getting here, that is where I have written H, is equal. That is what arithmetic sequence is talking about. A sequence that increases in an equal step. Like the first question or first example we treated, where we have 4, 2, 4, 6, 8. You can see that the increase is equal. 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2. This is arithmetic sequence. Why? It increases by an equal step. 2, 2, 2. Also, we had a question that sequence that was 1, 6, 11, 16. You discover that 6 minus 1 will give you 5. 11 minus 6, 5. And 16 minus 11, 5. So this is arithmetic sequence because it increases in an equal step. This plus 5. This plus 5 this plus 5 this, an equal step. So we call those first examples. There were about 4 or 5 of them. Those ones belong to what we call arithmetic sequences because they increase by an equal step. And then the second one we have, the second one is what we call geometric sequence. Geometric sequence. We had an example where it was multiply by 2, multiply by 2, times 2, times 2. So geometric sequences are sequences that increases in an equal ratio. In an equal ratio. It's not equal step. Arithmetic sequence is equal step, while geometrical is equal ratio. If it is times 2 or times 5 or whatever, equal ratio. That is the difference here. We had such when we had a question like this, that was 1, another 2, had 10, had 50. And what was our rule? Our rule was a term times 2. 5 times 2, 10. 10 times 5, 50. 50, I repeat. 2 times 5, 10. 10 times 5, 50. 50 times 5, 250. You can see it's an equal ratio, not equal step. So this is geometric sequence. Because the rule here, as we discovered, times 5. So know it that arithmetic sequence is a sequence that increases in an equal step, while geometric sequences are sequences that each of them increases in an equal ratio. And the first 4 or 5 examples we had were all arithmetic sequence, while the second one is geometric sequence. Remember to subscribe to sirMATHS to follow our weekly, which is daily, mathematical journey. Don't fail to do that. You will enjoy it. And we had examples of sequence. In each of them we find a rule, and we were able to add more terms to the given terms. And also we have also discussed the different types of sequence: arithmetic sequences, geometric sequences. Next week, by God's grace, we will meet. Don't fail to subscribe. Thank you.